If you're scared of spiders, never ever visit Mars. In March 2025, NASA's Perseverance rover found something looking like a bunch of tiny spider eggs on the surface of the red planet. This something is made up of hundreds of little round balls stuck together. What if all these eggs hatch? Will hordes of eight-legged creatures swarm the red planet? Doubtful. The thing found by Perseverance was just sitting there on a hill called Witch Hazel, near the edge of Jezero crater. On closer inspection, it turned out to be a weirdly shaped rock with a bit of Martian dust on it. Yeah, sadly, or luckily, those weren't Martian spider eggs. Even so, the formation really stood out from everything else around it. The Perseverance team named the weird rock St. Paul's Bay. It's what scientists call a float rock. This term means that it didn't form where it was found, but somehow got moved there. So, at the moment, we don't have enough clues to figure out its background and how it got that strange texture. But that's not the only mystery. Something had to move this rock from its original spot. One theory claims that the rock could have been created when a meteorite smashed into Mars. The powerful impact must have blasted rocks into the air, and those bits could have cooled down and formed the tiny balls we see now. If that's true, this rock might have come from really far away, and it could give us new info on how big impacts move stuff around on the red planet. NASA thinks the rock might have just rolled down Witch Hazel Hill. It could have come from one of the darker layers up on the hill. We have seen those layers from space. Now, the goal is to study Witch Hazel Hill more closely and find out if those layers are made of the same stuff as the St. Paul's Bay rock. If so, it might mean a few things. Maybe there was volcanic activity in that region, or a big meteor hit, or there might have been groundwater there in the past. If this theory turns out to be true, there's a chance that some of those rocks might hold tiny fossils from ancient microbes. That's why NASA is planning to bring some of the rocks back to Earth in the 2030s with the Mars Sample Return mission. We'll get to study them up close and maybe, just maybe, find signs of ancient Martian life. Now, the funniest thing about it all is that it isn't the first time scientists have dealt with arachnids on Mars. Spiders on Mars is actually the nickname for a weird-looking surface feature. In certain places on Mars, you can see big dark cracks that spread out like spider legs. Some are huge, over 3,000 feet wide. From above, they seriously look like a bunch of creepy crawlers moving across the planet. These spooky shapes were first spotted by Mars orbiters in 2003, and they've been showing up in satellite photos ever since. At first, no one had a clue what they were, but now, scientists think they form when carbon dioxide ice, dry ice, sitting on the surface, suddenly turns straight into gas. That fast change causes gas to shoot through the ice and carve out all those strange crackly patterns. An even cooler thing is that NASA scientists have been able to recreate those Mars spiders in the lab here on Earth. They built a special setup mimicking Mars's surface and watched tiny versions of the spiders form right in front of their eyes. The team had been trying to recreate those Mars spiders for 5 years. When it finally happened, they were overjoyed. Back in 2021, scientists managed to explain how those spider-like marks form on Mars using something called the Kiefer model. The basic idea is that in spring, sunlight shines through big, clear chunks of frozen carbon dioxide, aka dry ice. That heats the Martian ground underneath, and the ice starts turning straight into gas. The gas builds up under the ice, and when the pressure gets too intense, boom, the ice cracks. Gas shoots out, dragging dark sand and dust with it, leaving behind those spooky spider patterns once the ice melts in summer. The team tested this theory using a big special chamber nicknamed Dusty. Yeah, that's a real name. It's about the size of a barrel, and can recreate the freezing cold, super low pressure conditions on Mars. We're talking about -301 degrees Fahrenheit. The researchers also put fake Martian soil in the chamber and covered it with CO2 ice. Then they used a lamp underneath the soil to heat it up, just like the sun heats up Mars. Their experiments worked, and little spider shapes formed just like they do on the red planet. The study also revealed something new. The team found that ice formed inside the ground too, and it caused the soil to crack along with the ice. This might explain why the spider's legs are so zigzagged instead of straight, like we might expect. Next, they want to keep doing experiments to figure out more about the Martian spiders, like why they only show up in some places on Mars and why they aren't getting more common over time. The red planet is apparently set on playing tricks on people from Earth. For example, in April 2023, NASA's Curiosity rover took a little break from searching for signs of ancient water on Mars and stumbled upon something curious: a travel book. Later, scientists realized that it wasn't really a book, just a rock. But it does look like a little hardcover with a page frozen mid-turn. This book rock is tiny, measuring only about 1 inch wide. So it might not hold any ancient Martian stories, but at least it's travel size. Then in January 2023, the University of Arizona shared another bizarre image: a rock formation that looked like the face of a giant teddy bear. It had two distinct beady eyes, a button nose, and an upturned mouth. It was captured by NASA's Mars Reconnaissance Orbiter, which was orbiting the red planet at the time. Scientists from the University of Arizona explained that the teddy bear face was likely just a natural formation, like a broken up hill or mound in the center of an ancient crater. Another cool find occurred in February 2022. The Curiosity rover spotted something that could only be described as a tiny flower made of minerals. It looks like little coral branches, but it's actually a mineral deposit, which is pretty rare to see in a flower-like shape. Most of these kinds of deposits are formed when ancient water mixes with rocks on the Martian surface, so they're not exactly new to scientists. But this one is unique, since it looks like a tiny plant or flower. Now, the next discovery is even wilder. Once, the Curiosity rover snapped a pic of what looked like a perfect doorway in a Martian cliff. Naturally, people started wondering if it was some kind of secret entrance, or maybe a hidden base for astronauts. But in reality, it's just a really cool rock formation. Winds and erosion carved away at the rock over time, creating a perfect symmetrical shape. Going even deeper into the past, back in 2018, a researcher noticed weird stick-like shapes in an image and thought they looked like fossilized animal footprints. Unfortunately, NASA quickly shot down the idea. Those tracks turned out to be salt deposits that formed in areas where water evaporated. You can find something similar on Earth too, for example, in dry lake beds. So, while it's pretty interesting that there's more proof that Mars used to have rivers and lakes, these tracks aren't evidence of life, just a quirky rock formation. Now, the next find is absolutely amazing. NASA's Opportunity rover found round, blueberry-like rocks on Mars back in 2004. But those aren't the kind you eat with your cereal. The blueberries you're looking at are made of iron, and they're evidence that Mars used to have a lot of water. Over billions of years, water smoothed them out and created these little balls. Scientists think that they formed when Mars was much wetter than it is now. The iron-rich blueberries are a pretty big deal because they show that Mars could have been a very different place a long time ago. Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called ERAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both ERAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The 2 detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. a big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be 2 unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun. Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide-and-seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect. On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guess said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, the team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new: a bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things: really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear: the typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion, which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters overmassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet.
Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, It could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did this zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space. Thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow.
You're traveling through space, trying to get through an especially rough patch. You gotta dodge asteroids, space debris, wandering black holes. No, it's not an episode of a sci-fi series, at least not completely. For the first time ever, astronomers have found a black hole that's completely alone, drifting through space with no stars or planets nearby. This black hole is about 5,000 light-years away from us in our own Milky Way galaxy. Do we need to look for a hero with superpowers to save Earth? First things first, a black hole is a place in space where gravity pulls so much that nothing, not even light, can get out of this region. The gravity is so strong there because a huge amount of matter is squeezed into a tiny space. Supermassive black holes, hundreds of thousands to billions of times the mass of our Sun, are often found at the centers of galaxies. Most of them stay put or move at a very, very slow pace. But the newly discovered black hole is much weirder than anything we've seen before. First of all, it tries to avoid commitment. It's lonely, with no companion star or home galaxy. An even stranger thing is that it's zooming through space at a speed of 31 miles per second. What might be the reason for this speedy cosmic journey? Let's look at the following imaginary scenario. One day, a really massive star exploded in a supernova. It was the very star that formed our black hole. The resulting blast gave the new black hole a massive kick and sent it flying through the galaxy, starting its unbelievable voyage. Now, it's only one of a few possible explanations, but it sounds quite plausible. I bet you can't help but think, what if this wandering black hole decides to visit our solar system? Are we doomed? Scientists tell you to relax and breathe out. This black hole is very far away, and your chances of ever encountering it are infinitesimal, if any. Plus, this black hole is totally quiet and dark at the moment. One day, it might wake up and start glowing. It'll happen if it begins to eat something. In the near future, powerful new telescopes may find many more wandering black holes like this one. Usually, black holes are super hard to find because they don't give off any light. You can only detect them when they're eating nearby matter. That makes them glow brightly. Or when they have a companion star. In this case, it moves in a strange way, which gives away the presence of a black hole. But this newly discovered black hole is lonely, totally by itself. There's no glowing, no companion star moving hectically. So, how did scientists spot our cosmic wanderer? They used something called gravitational microlensing. That's when the black hole's gravity bends and magnifies the light from a star located behind it, kind of like using a magnifying glass, hence the name. This method allowed scientists to detect the black hole even though it was completely dark. All in all, black holes are fascinating things, and some of them are truly unique, like these biggest black holes ever found. You see, almost every galaxy has a supermassive black hole at its center. They're huge, with masses millions to billions of times bigger than our Sun. One of those is called TON 618. It's a really huge and powerful black hole that's part of something called a quasar, a super bright spot in space emitting incredible amounts of energy. TON 618 is very, very far away, about 18.2 billion light-years from Earth. And it's 40 billion times heavier than our Sun. There are also black holes that feed on their own kind. Black holes are known for devouring anything that gets too close. And this anything can include not only stars and gas, but also other black holes. Scientists witnessed a ginormous black hole at the heart of one galaxy being swallowed by an even larger black hole in another galaxy. It was the first time we detected such an event. The discovery was made using NASA's Chandra X-ray Observatory. One black hole weighs about 30 million times the mass of the Sun, while the other has at least 1 million times the mass of the Sun. Then, there is a bullet-shooting black hole. Apparently, black holes don't just swallow matter, they can also shoot it out. For example, astronomers studied one relatively small black hole, which is about 28,000 light-years from Earth and weighs between 5 to 10 times the mass of the Sun. And they saw how this black hole pulled matter off a companion star and then blasted some of it out in the form of huge bullets of gas. These bullets are super fast. They move at nearly a quarter the speed of light. Some black holes spin incredibly fast, twisting space around them at extreme speeds. One example is a black hole located in the constellation Agila, about 35,000 light-years from Earth. This black hole spins at a staggering speed of more than 950 times per second. If you could place an object on the edge of this black hole's event horizon, it would spin around the black hole at 333 million miles per hour. That's nearly half the speed of light. The smallest black hole discovered so far has been nicknamed the unicorn. Located 1,500 light-years away from Earth, it's around 3 times the mass of our Sun. This makes it very close to the smallest possible size for a stable black hole. While black holes themselves are far away and difficult to study directly, scientists find new clever ways to study their properties right here on Earth. They've been able to recreate certain features of black holes in the lab. For example, black holes have a gravitational pull so strong that nothing, including light, can escape once it crosses the event horizon. To understand this better, researchers have created an artificial event horizon using fiber optics. They've also been able to simulate Hawking radiation, the kind that likely escapes black holes, by setting up experiments in the lab. These lab-created mini black holes help scientists understand the mysterious properties of real black holes. There are several types of black holes, and each of them is born in its own unique way. Primordial black holes are believed to have formed right after the Big Bang, when the universe was very young. Stellar black holes form when a massive star collapses in on itself. This causes a supernova, where the outer layers of the star explode into space, and the core turns into a black hole. As for supermassive black holes, they're thought to have formed alongside the galaxies they're in. The size of the black hole is usually related to the size and mass of the galaxy. Despite what many believe, black holes don't roam the universe randomly, looking to swallow planets. They obey gravity like anything else in space. So, for a black hole to affect Earth, it would have to be very close, much closer than any black hole is to us right now. Even if a black hole the same mass as the Sun replaced our Sun, Earth wouldn't fall into it. The black hole would still have the same gravity as the Sun, and Earth would continue orbiting it just like it orbits the Sun today. It would get much colder though, so we wouldn't survive such a replacement in any case. But don't worry, our Sun will never turn into a black hole. It doesn't have enough mass to do so. Instead, in about 5 billion years, when the Sun reaches the end of its life, it will become a red giant star. After using up its fuel, it will shed its outer layers, creating a glowing ring of gas called a planetary nebula. What's left will be a cooling white dwarf star. Guess the riddle. It's moving at 5 miles per second. It makes one circle around Earth every 90 minutes. Within 24 hours, it sees 16 sunrises and sunsets. It also observes many strange phenomena, like gigantic bizarre symbols written in a desert. You probably already know what it is. The International Space Station. There are a lot of things we don't notice here on Earth, but if we step back, we'll see some pretty strange stuff happening on the planet. Most often, astronauts notice these mysterious things, and recently, they've seen weird patterns in a deserted area of Tunis. They aren't like fake crop circles that were popular in the early 2000s. You may think these strange hieroglyphs have an unearthly origin. They're quite large. That's how astronauts could see them from space. But why doesn't anyone talk about them on Earth? Do Tunisians know what's going on there? In many movies and in real life, secret organizations hide information about some kind of extraterrestrial things. You might have also noticed that most videos about strange phenomena taken by eyewitnesses have terrible quality, as if the operator is always shooting on an old VHS camera. But in the case of the ISS, everything is different. The mysterious symbols were captured on a 4K camera mounted on board the ISS. And the owner of this camera is Sen Corporation Limited, which provides video streaming from space to individuals and businesses. And do you know what the principle of this company is? They strive to make space data publicly available and useful. Thanks to the high quality of the video and open access, the mystery of extraterrestrial technology has been solved. Do you know what it is? Think for yourself and see other strange phenomena that astronauts have observed. Perhaps the following riddles will lead you to the right answer, but if you fail, you will get the answer at the end of the video. Meet NASA astronaut Matthew Dominic. He likes to take pictures from the ISS and post them on the internet. After 6 months of working in Earth's orbit, he shared a mysterious phenomenon with us. You can see most of Asia from an altitude of about 250 miles. There are flashes of lightning, city lights, and a strange red glow. Dominic admitted that he wasn't sure about its origin. Considering the glow is so visible from such a long distance, this must be something big. Try to guess. Here's a clue. Perhaps squids are guilty of this strange visual effect. But no, it's not a giant glowing kraken. You'll find the answer at the end. The following phenomenon occurred not on Earth, but above it. Take a look at this golden red glow in the atmosphere. The ISS took this photo while flying over the Pacific Ocean, northeast of Papua New Guinea. If you think it's pulverized gold, then you're wrong. This is probably the most difficult puzzle in this video. Do you know anything about chemistry, physics, and astronomy? If not, then you're unlikely to answer this riddle. Wait, you'll get the answer soon. This picture was taken by an ISS astronaut during a flyby over Southeast Asia in 2021. Two shimmering blue balls of light appeared in the dark and slightly ominous atmosphere of Earth. One was flickering over the Gulf of Thailand, and the other was glowing near the South China Sea. The difficulty in solving this phenomenon lies in the fact that not one, but two scientific phenomena are taking place here. Lightning, reflection of moonlight from ice particles, spaceships from another planet? What do you think it is? Do you want to get an answer? Wait a bit. So the first mystery is those strange hieroglyphs in the desert. Do you have any ideas? I must warn you though, the truth about this phenomenon may disappoint you a little. These are not symbols made by an extraterrestrial civilization. These are agricultural patterns. Someone just plowed the land or planted vegetables. It doesn't seem strange from below, but from above, it looks like an unknown language or a cipher. So, the next mystery is the red light. Some internet users said it could have been an erupting volcano. Others suggested that commercial vessels emit a red light to catch squid. Fishers use this color to attract sea creatures. So maybe it was a hunt on the giant squid after all. And one user claimed that those red lights belonged to a giant fishing fleet. And its red light can be seen in the nighttime images taken by some satellites. It's time to deal with the most difficult mystery, the golden red glow. If you understand the atmosphere of our planet and know about the chemical interaction between the elements of the periodic table, then you've probably guessed what it is. If not, then here's a simple answer. A golden red glow appears as sunlight interacts with molecules and atoms in the Earth's atmosphere. Now let's take a closer look at this. Ultraviolet light falls on molecules such as oxygen, ozone, sodium, and nitrogen. Light stimulates these cells, meaning it charges them with energy during the day, causing them to separate and excite the electrons inside. Then, these charged particles collide with each other and release energy. As a result of this process, a mesmerizing glow appears. It's mostly oxygen that gives the red color to this glow. The golden light appears because of sodium particles. Scientists divide this phenomenon into three categories: day glow, twilight glow, and night glow. Depending on the illumination of the atmosphere by sunlight and the position of the observer, these lights have unique characteristics. Such a fascinating phenomenon not only shows the visual aesthetics of our planet, but also helps scientists better study the upper atmosphere. And finally, the answer to the fourth riddle. We have two blue lights. Both have different natures. Let's deal with the first one. The blue light over the Gulf of Thailand was caused by a thunderstorm. But it's not that simple. If you observe Earth from the ISS, you may not always see lightning flashes during thunderstorms because they're usually hidden by clouds. This time, the photographer from the ISS was lucky. There was a gap in the clouds. Lightning illuminated the surrounding walls of this cloud and produced this blue glowing ring. Do you know that a blue thunderstorm is not the most unusual phenomenon in the sky? Red lightning flashes can appear too. They're called sprites. They occur above clouds during an ordinary lightning strike and extend to a height of up to 10 miles. That's why it's hard for us to see them from the ground. Sprites can also extend upward along the trajectory of a narrow cone, like fans. And at this moment, they can glow with blue light. Another cool phenomenon is called elves. These are giant expanding flashes of light in the shape of a pancake. They can reach thousands of miles across and also appear during thunderstorms. Seeing these pancakes is pretty difficult because they exist for less than 1,000th of a second. But what about the second glow? Things get a little more complicated here. The reason for this blue flash is the moon. It seems to us that our satellite glows by itself at night, but it just reflects the sunlight that falls on it. The light from the moon passes through the atmosphere, and the magic happens. We see a blue sky during the day because the sun's rays get scattered in the atmosphere. It's as if they pass through special filters. The light reflected from the moon is also scattered, passes through these filters, and turns blue. But why don't we see this glow at night? Because it's too weak compared to the daytime glow of the sun. But from a certain angle and at a certain height, this blue moonlight can be seen. Astronauts from the ISS managed to catch this scattering. It's like turning the sky blue, only a smaller version. But why blue? Light consists of different colors, and each of them has its own wavelength. Blue has the shortest wavelength, so it's the easiest to scatter.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Hessian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggest it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler-186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler-186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it ExoVenus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable.
Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot, so the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda, yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
So, in the end, will the sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the Earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in 1 billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Mobile Cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask. But for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there, and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances. And somehow, life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in 1 billion years.
And we have liftoff of the Mars Global Surveyor as America begins its journey back to the Red Planet.
There's a weird structure on Mars, a square, a near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth, there were no plants or animals, just microscopic life trying to survive. So, Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, what happened, and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned, Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory: dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, people freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything, from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock.
Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago, but they appear much younger than expected. Typically found in clusters of 10 to 40, they're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger, and the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the moon. In its early years, the moon was just a molten world, shaking from intense volcanic and seismic activity. So, the moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out, 4.43 billion years ago. This was a huge turning point, not just for the moon, but for Earth too. After all, the giant impact that formed the moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The moon gradually cooled and contracted. And now look at this modern-day rocky sphere illuminating our nights. But the moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the moon's continued activity. As it cools, the moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria. See these large, dark patches on the moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the moon actually affect humans? In a sense, it can. The moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, there's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the moon's surface, grinding much of it into powder. Unlike Earth, the moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, constant exposure to solar wind has given the regolith an electrostatic charge, making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, Scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term moon missions much cheaper and more practical, helping astronauts live and work on the moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show. Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path. A white dwarf star, 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we missed the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There is a high chance they'll find extraterrestrial creatures while you and I are still around.
You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo. There's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So, we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet, different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, It takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window.
You take off from Earth and park your spacecraft somewhere near the Moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Thea, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon it gets so high that it triggers a nuclear chain reaction. Another second and bam! There's an explosion so powerful that the shockwaves travel far into dark space. And the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Thea. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Thea was kind of a ball Jupiter and Venus played with. Venus was pulling Thea in one direction, then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Thea move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Thea is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Thea is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Thea itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Thea touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Thea happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shockwave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon, it gets filled with boiling lava. The remnants of Thea and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Thea. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Thea that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Thea, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Thea are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see 2 huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Thea. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Thea might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Thea did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Thea remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there has been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there.
Let's cut the Earth in half. You can see all of its layers. Here's the inner core. It's about 40 times hotter than the inside of your oven. That's the mantle, an ocean of hot lava. Here comes the crust of the Earth, the solid surface on which our civilization lives. But if you look up, there are many layers besides the atmosphere and the ozone layer. Scientists recently discovered a strange bubble here, which protects our planet from radiation. And nope, it's not the Earth's magnetic field. This bubble is made of radio waves. Our planet grows like a Christmas tree in the radio spectrum. But we're interested in low-frequency waves, the ones that let us keep in touch with submarines. So, radio waves are like light waves, or regular ocean waves. Look at this one. The distance between the two peaks is the wavelength, and the number of these waves over a period of time is the frequency. For example, there are 10 waves in this interval of 1 second. So, can you guess the frequency of this wave? Yep, it's 10 Hertz. Cell phones use waves with a frequency of 300 to 3000 megahertz. So, add 6 more zeros to that number. But waves of that frequency don't penetrate barriers well. Think of how you lose your cell phone connection when you're driving through a tunnel. That's because there is metal inside. It's a conductive material that weakens the radio waves a lot. Salt water is also a kind of conductor. So, if the submarine is deep enough, the thick layer of water weakens the signal, and we lose communication. To maintain it, we send fewer waves but make them longer. In the same amount of time, the frequency of the short waves will be much higher than the frequency of the long waves. That's why they're called very low frequency waves. But, as it turns out, these waves travel all over the Earth and even into space. This is where things get interesting. The waves collide with particles of radiation from the Sun. We think of the Sun as a friendly giant giving us light and heat, but it actually emits a lot of harmful radiation. Each flare, or the electrical discharge of material on our home star, causes an even greater burst of radiation. These particles fly to our planet, just as radio waves do. They travel 93 million miles from the Sun to Earth in 8 minutes and crash into our bubble, which acts as a shield. Basically, radiation particles from the Sun accumulate in the radiation belts around the Earth. Our planet's magnetic field traps them, and a recently discovered bubble of very low-frequency waves lies right below this radiation belt. It helps us repel some of the harmful emissions. Analysis of old studies confirmed that the radiation belts used to be much lower and closer to Earth. But when our civilization began to use radio actively, our waves raised that belt higher. No one expected such an effect from simple radio waves, but it'll give us a way to protect astronauts in the future. When you're on Earth, its magnetic field keeps you safe from radiation. You can physically see it when charged solar wind particles make the air particles at the poles of our planet glow. This is an aurora. Next time you admire this beauty, know that it's actually the Earth saving you from some extremely harmful rays. But if you're outside the Earth's magnetic field, somewhere in space, I have bad news for you. Nothing protects you there. This is a big problem for astronauts who spend months on the International Space Station. Perhaps scientists will learn to create protective bubbles of very low frequency waves around space stations and spacecraft. The same is true for other planets. We're probably going to colonize Mars. There is no magnetic field there, and nothing can protect you from radiation. But if you create an artificial bubble there, you can reduce the harmful radiation. Another invisible bubble protecting us is the atmosphere. It's like a layer cake or an onion. Each level of the atmosphere has its own properties. The lowest layer that we live in is the troposphere. This layer contains 80% of the weight of all the air on the planet. It's also the main place where water vapor lives. And this is where the machine called weather works. The sun sends rays of energy to the Earth. Our planet's surface reflects them and heats the air in the troposphere. This makes it move and change places with the cold air, so all the wind, cyclones, storms, and tornadoes only happen in the troposphere, up to about 7.5 miles high. That's why commercial planes fly at an altitude of around 6 miles. The wind or other bad weather conditions hardly affect this area, and the air here is not as dense as it is down on Earth. Flying 1 mile above sea level is like moving through a biscuit. It's hard, but at a 6-mile altitude, flying feels like moving through light whipped cream. The plane almost feels no resistance, so it's a win-win. They save fuel and keep the passengers safe. A couple of significant downsides are that it's very cold and you can't breathe there. It's cold because there are very few air molecules to absorb heat from the ground and transfer it to each other. You wouldn't be able to breathe here for the same reason. That's why planes are equipped with oxygen masks, just in case. Let's go a little here. This is the stratosphere. There's even fewer air molecules up here, and that's where the weather probes fly. They're the kind of small balloons with computers people use to predict the weather. This part of the atmosphere also contains the well-known ozone layer. This is our shield against harmful ultraviolet radiation. Ozone is almost the same as oxygen, except it has 3 atoms in it. When harmful ultraviolet rays enter our atmosphere, they crash into the O3 molecule. The ray breaks the molecule into O2 and another oxygen atom. The ray itself is converted into heat, but the ozone regenerates quickly. A single oxygen atom joins the O2, and the ozone molecule is ready to protect us again. It's the invisible shield that protects us from radiation. It gave birth to all life on Earth. As our civilization developed, we started to emit freon gas into the atmosphere. We used to fill our old refrigerators with it. A single chlorine atom would detach from a freon molecule when in the air, and then it would bind a single oxygen atom. Now, the ozone can't regenerate like it used to. Fortunately, we banned the use of such harmful gases, and the ozone layer began to regenerate. Scientists expect it to fully recover in the middle of the 21st century. The stratosphere ends at about 31 miles. The next layer is the mesosphere, the coldest of them all. On average, it's about negative 140 degrees Fahrenheit. That's 5 times colder than your freezer. This is the layer of the atmosphere where incoming meteors start to ignite because of friction in the air. Then they will eventually burn up completely. The air here is too thin for airplanes or balloons to fly, but it's still too dense for satellites. So, this layer of the atmosphere is not well studied. The next layer extends from 55 miles above sea level to about 500. That's a little more than the distance between Las Vegas and San Francisco. Kármán line is situated in this layer of the atmosphere. This is the boundary between our planet and space. The thermosphere is where all our spacecraft and satellites fly. It's also home to the International Space Station. The temperature rises extremely. The air here is about 10 times hotter than your oven can produce. It's all due to solar activity. But you would never be able to feel this heat. The air molecules that carry the heat here are so small that you would literally float between them. Imagine a giant pool with only 3 drops of water. That's the thermosphere. And the highest layer of our atmosphere is the exosphere. This is the widest layer of our air bubble. Scientists believe its boundaries are about halfway to the moon at 120,000 miles. This is the point where the pressure of solar radiation begins to exceed the Earth's gravity. It's still part of our atmosphere. This means that astronauts who went on various space missions and have been on the ISS have actually never left the Earth's atmosphere.
2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable? For us. Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is. And that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxies by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the 4th planet in its system, and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect. But when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency. Toys Were Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys Were Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day, or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of 2 exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these 2 Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri b is the closest Earth-mass exoplanet at 4.2 light-years away. So, these 2 new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay, since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with two instruments, espresso and Carminis. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, "Nature seems bent on showing us that Earth-like planets are very common. With these two, we now know 7 in planetary systems quite near to the Sun. Who knew our neighbors could be so friendly?" In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP 890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The two planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling, Bob, is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the second most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys R Us, Wolfie and her mama will all be out there waiting for us. The search for E.T. is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. You know, twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, Is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is, but we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our TESS satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The TESS satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the TESS satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot, 4-inch wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry him there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information, its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in.
Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called gravis stars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe, dark energy, and even other dimensions. Let's start with gravity. Over a century ago, Albert Einstein helped us understand how gravity works. Turns out, it's not just something that pulls things on Earth and makes apples fall on Newton's head. It's much wilder. It's about warping the very fabric of existence itself. Let's say you toss a heavy ball, like a bowling ball, onto the middle of your bed. What happens to the sheets? They dip, don't they? They stretch and sag around the ball. Now, if you roll a smaller ball, like a marble, across the bed, it doesn't move in a straight line anymore. Instead, it starts circling the heavy ball, rolling closer and closer as if the heavy ball is pulling it in. That's gravity. But instead of bed sheets, we're talking about the fabric of space and time itself, or space-time for short. Heavy objects like planets and stars make dents in space-time, and moons, planets, or even light move along these dents. Gravity is the curve that tells them where to go. In that case, you can guess that black holes are like the ultimate heavy balls. The heaviest, in fact. The gravity is so strong, it shrinks them, making them smaller and smaller. So tiny, they could fit in the palm of your hand, but with the mass of several suns. Some of them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But gravastars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field. Something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of gravastars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravastars were dreamed up by two physics professors, Paul Mazur and Emil Mottola, in 2006. They tried to think what else besides black holes could happen when a massive star collapses on itself. That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a gravistar, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that gravastars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller gravistar inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of gravastars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single gravistar might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a gravistar, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a gravistar. Of course, these are all just speculations for now. But where are all those gravastars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in spacetime, hasn't found clear evidence of gravastars. Another problem is that gravastars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized, if gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach gravastars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But gravastars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they check the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that gravastars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity.
So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle, it's way thicker. And this is the core. Wait, what's happening here? Uh-oh, the core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's central Anatolian plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time. And as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian Plateau has risen for around a half mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian Plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow! That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.